Okay. Hopefully I did this correctly. I'm 90% sure I did, but I did not double check first. Um, okay, I did. That's awesome. So, hello everyone. Chloe here. This is definitely a new setup for me. I'm back to having my face in the videos. I don't really know why. I haven't really made a decision on that yet. But welcome to the messy office back in Canada. And today I'm going to be discussing contributing to uncloak.org. So Uncloak, if you have no clue what it is, you can just visit it right now on the internet. It's live, uncloak.org. And hopefully, no matter when you watch this in the future, it is still live. That would be super cool. Like even if this was watched like 10 years from now or something. But yeah, I'm Chloe, co-founder of the Marma J Foundation. We're a nonprofit in Canada that works to leverage Web3 blockchain technology for social good. Yeah. And through that, I guess, as part of the Marma J Research DAO, I suppose, I am contributing to Uncloak as much as I possibly can. Um, a lot's been going on over the past couple of weeks, and so my contributions may not be as what's the word? Um, uh, weighty as I would want them to be. But still, I think that the whole idea of a site like Uncloak is that every contribution is meaningful in some way, and hopefully with like the knowledge graph that's coming together, all contributions can also kind of connect together as well in some kind of meaningful way. And so, if you have no clue what I mean by like a knowledge graph, I think what's cool about Uncloak is that right now, even though the site's only been live for like a month or something, maybe even I don't know how long. I'll show on GitHub. Oh, on GitHub we can kind of, because what today's about is contributing on GitHub, so we'll get to that soon. But on GitHub you can kind of actually go to the Uncloak page and see when the initial commit was 26 days ago, so not even a month. So there you go. The site's not even live for a month, but you can already see how the README is connected to the contributor guide, which we'll go through today, how it's connected to the study group, right? And how it's connected to the topic of cryptography for now. And you can kind of almost already start visualizing how. I think if I click the so you can expand this and kind of see what I'm talking about. The README we're going to go through now is connected to the contributor guide, the syllabus for the study group that we're running, Thor and I. I'm trying my best to support as much as possible, and the topic of cryptography. So I think it's pretty cool. You can already start seeing these things. So we can start, you could read through this yourself, so I'm not going to read through the whole thing. But it kind of starts off with saying, this is a community maintained knowledge wiki experiment. That's like a pretty good way of putting it. The best way I try and explain it is like wiki, hopefully eventually mixed with like Reddit type of commenting and like community collaboration on like knowledge sharing. So it's aiming to increase the accessibility of cryptography for developers, researchers, and everyone else. So for now, we are focusing on cryptography. That's why there is only one topic here. But in my opinion, it's pretty realistic to kind of start visualizing how other topics might start also being relevant here. And so you can kind of see how there's topics on zero knowledge, related topics in cryptography, post quantum cryptography, hash functions, hardware, general. There's a lot of. Thor, you've. Thor's been busy. But I think what's really cool again is how all of this is actually managed on a GitHub repo. And so it's all managed on Obsidian, right? On Obsidian Publish. And every single, cryptanalysis, for example, side channel attacks and all the algorithms here are also possible to be seen here. Side channel attacks, algorithms, and birthday attacks, exclusion attacks. And so anyone that wants to also contribute to the website, that's right here live in the knowledge graph that's able to be seen in the global graph and how crazy that is. Okay, let's back out of that real quick. I'll kind of dig into that in a bit. But the point is, anyone who wants to contribute can do so with their GitHub profile. So I'm logged into my GitHub profile right here, signed in as Doulos819. My little tagline is spread the love, and I can kind of sign out. And so if you've never even heard of GitHub before, this is probably what you'll see. And so generally you can kind of sign up. It'll go through, okay, this is a bit much, honestly, but it'll ask you for your email and it'll go through a bunch of stuff. I mean, you can go, it's really straightforward, honestly, setting up on GitHub for the first time. If you already have an account, you just sign in with that email and your password. You hit sign in, and then boom, you are signed in. This is like my homepage I land on when I'm on GitHub. You can see like all these random repositories that I've like just forked or created for various reasons, usually just to play around with things. But one of them that I've kind of have here that I've starred and forked away as well under like Chloe C. I have my own little repo for it that I try and kind of have fun on from time to time and learn things and play around with things. I don't break them on the main repo, but I can do my own things on my own repo. So if you have no clue what a repo is, it's a repository where you put a bunch of files, and this is the Uncloak repository that kind of holds all the information for the Uncloak site. So, for example, let's go to a topic that I am relatively well versed in, the course, the study group, and we will I didn't actually check to make sure the audio was working. I did check to make sure
This is the Uncloak that kind of holds all.
The audio is working, although I don't necessarily enjoy the kind of lighting I'm getting right now, but the light bulb blew on my lamp, so that's just the way it's going to have to be. Okay, so in this course, right, so let's go maybe to the syllabus so we can explain a little bit about the course. And this graph is quite a bit larger, so I think it's pretty cool already, again, being able to see, again, you can't making this more efficient maybe would be able to kind of drag the study group syllabus kind of out here, and then being able to kind of see how it connects to the README and being able to drag things out. But it's not that easy to do. Either way, you can kind of see how, how there's already kind of empty pages for session 9, session 10, session 12, notes that are available. There's solutions for some of them. So if you kind of highlight homework 1 solutions, it connects to session 2 notes and session 1 notes. If you connect to, session 1 notes, you can kind of see again how that connects. If you go to then, session 2 notes, it's a bit hard to see, but now you can see how session 2 notes connects to session 3 notes, okay? And the date and everything as well. And then, if you went to session 3 notes, it is not yet connected to session 4 because we're not there yet. So currently, everything is only connected to the syllabus because it hasn't been actually written in yet. But you can actually see how already there is pages created for all of this, but they're not linked yet because they're not actually done. So it's kind of interesting already to me to see how the website is coming together and how people might be able to traverse the knowledge and see where to go in a visual way, not just through kind of the long, eventually there's going to be a long scroll bar, right, at the end here of, homework 1, week 2, week 3, week 4, all the way to week 16, the solutions, the answers, the questions, the exercises, extra readings, all of that. And so now let's go to week 2 exercises. Actually, on the syllabus, we can talk a bit about the study group. Again, I was kind of just showing the graph for the study group. So the study group in general is a 4-month, open to the public, Rust cryptography engineering weekly study group, covering topics in cryptography engineering, design principles, and practical application, which is a textbook, came out in 2010. And it goes over a lot of the high-level overview of how to actually use these cryptographic, how to use different cryptography tools like block ciphers and hash functions and use them together in practical applications. So the study group runs over 16 weeks. There's various exercises in the textbook and extra readings that are added to that as well that make up the study group. There's some extra resources here, which, people that want to partake in the study group can read through. The number 3 article is wonderful. I have not completed it yet. I mean, I don't even know if you can actually say you could ever complete it, but I haven't read through it completely once yet. I'm still kind of working through that. And Practical Cryptography for Developers is a great resource as well. So again, it's very similar to the textbook, but again, focusing on actual code that you can run through, which is pretty cool as well. So I mean, there's so many resources to go through, and talking about why this study group is happening. The fact that you can join the Discord channel to contribute as well. So again, contribution doesn't have to be necessarily through GitHub. People can contribute simply by joining the Discord channel, partaking in the study group, learning cryptography engineering for themselves, or trying to get more proficient in applied cryptography engineering. And of course, then finding ways to contribute to the website and make their contributions lasting, in my opinion, is an efficient way to try and contribute. And so why not? If you just want to use the tools, not necessarily do crypto engineering, then you might not necessarily get too much out of the study group. You can still join, very fun. But there's a lot of other ways to kind of just get started and start coding or programming with ZK tools, for example. So for example, the study group meets every Friday, but in my opinion, the actual lecture period on Fridays is more of a coming together of community, a way to kind of share ideas, and ask questions live, and kind of hopefully get some live feedback. But a lot of the work for the study group happens throughout the week. A lot of it in the Discord channel. The Discord's actually quite active with people asking questions. There's a little mini forum in there, which is really cool. And a lot of code sharing and everything else. So a lot of the study group work happens either individually, answering questions, or just in the Discord, or just different Discord study groups. But there is a weekly kind of live lecture that's streamed to YouTube, and sessions are recorded and posted to YouTube. So week 1, went through chapters 1 and 2. The reading was assigned, chapter 2 and chapter 23. Relatively straightforward, honestly. So chapters 1, 2, and 23, involving experts, actually was pretty interesting. I really enjoyed that chapter. I suffer from constant imposter syndrome, but I definitely know that I'm ignorant on many topics, and I try never to lead alone, and always have community members telling me when I'm wrong on things, so I know what to learn. But anyways, the idea of involving experts in what you're doing is super important, especially in cryptography, where one mistake technically could compromise the security of the entire system, and I guess technically usually does, maybe, if it's attackable, I guess. But yeah, the extra readings here as well, and yeah, that's kind of how the course is laid out. And so many people are contributing in the Discord. Just want to make that very clear. Not all contributions have to be on GitHub. They can just be, by participating in the study group as well. But for session 2, if we scroll down, we can see how, we covered chapter 2, assigned reading for the next week, chapters 3 and 4, familiarizing with NIST standards, block cipher techniques. There was a poll, right? So this is the notes for the class. And this is the exercises that were kind of assigned for last week, for example. So, in chapter 3, how much space would be required to store a table for an entire idealized block cipher that operates on 64-bit blocks and has 80-bit keys? In my opinion, this is an interesting, it's just a math problem, and for me that was actually quite difficult to kind of, at least to know I was clear about. So I kind of, Thor and I worked on some of these questions today together, and I'm really appreciative of the time. But I kind of intuitively, it was how I understood it, where it was trying to show you the difficulty of storing all of the keys for kind of a block cipher. And so just kind of saying, how much would it cost if you did want to do it with a block cipher that operates on 64-bit blocks and 80-bit keys, and I guess showing how difficult that would be, but it's maybe manageable. But then, I guess if you started doing the math for, maybe 128-bit blocks, maybe even larger keys, whatever, how that might look. And there is a kind of a general equation for that, which I thought was pretty cool as well. How these things can usually always be generalized, which is pretty cool. And there's, this was again another math equation which I felt was, this one was relatively straightforward again. Again, the typical computer science math problems are always difficult for me to like reason if I'm right or wrong. Like I can come up with like an idea or like an answer, but like usually I don't have enough practice to know like what the right notation is to write it in. Like I can reason things intuitively relatively well, I guess, but then like notating it the correct way is difficult for me. So then again, the study group's helpful for me to get like the more formal way of writing things out. But anyways, going through OpenSSL, and then I actually found like a way to like an answer sheet that kind of had these answers solved in the terminal, using the CLI for OpenSSL, which I thought was super cool. I didn't even know, so I want to kind of find the library for that and see what else I can kind of play around with using that. I think it's easier for me. Again, I like using the CLI. I don't really like writing code that much, like writing Rust. And I know the whole point is to do all of this in Rust for this study group. But I think for me specifically, realizing that I can do all of this stuff just in Bash and like just do it in the terminal is super cool. Because again, Bash or just doing it in the terminal with CLI is useful on any machine, whereas obviously programming languages change and adapt over time. But there was a typo somewhere that I wanted to actually fix and do live so that I can actually show, excuse me, I have some water here, what it looks like to contribute, even if the contribution is tiny. Here you go. Here is my typo. I feel terrible for it because I wrote the LaTeX wrong out of the textbook, and then I was actually reading through this attack a few times, and I kept being so confused. I was like, okay, so suppose you, as an attacker, observe the following 32-byte ciphertext C in hex. So the attacker sees this encrypted message, this ciphertext. And then you see the following 32-byte ciphertext C prime, also in hex. Okay, so you're seeing two different encrypted messages. You can see they're different because this is like 51 and this is 46 at the beginning. So they're different encrypted messages. And so suppose these ciphertexts were generated using CTR mode, so I guess counter mode, with the same nonce. So instead of using a different nonce and starting with a different number, which would encrypt these things differently, the same nonce was used, which is insecure, from a very high level, I guess. The nonce is implicit, so it is not. So it tells you right here what that means. So it is not included in the ciphertext. So generally, if the nonce wasn't implicit and it had to be included, the first few bytes maybe or whatever amount of storage would be this nonce, this number to signify what number you're using. But they're saying that actually it's implicit, so you don't have to actually worry about that. It's something that's known by the protocol, but it's not included, or maybe known by either of the parties, but not included in the actual ciphertext. Okay, so you know that you don't have to do any extra math or craziness. So sounds good. You also know that the plain text. So this is the part that I kept anyways, you know that the plain text corresponding to this first ciphertext is this plain text here. So this is the plain text. It got encrypted to be this, right? Hex, 32-byte hex information here. And then, so now it's saying what information, if any, can you infer about the plain text P? So I was getting so confused because I was like, wait, you have the plain text P here, and what information can you infer? And I'm like, what? This doesn't make any sense. I'm so lost here. And it actually turns out I'm just silly, and I just wrote it's supposed to be P prime, obviously, right? So because you know C prime and hex, what can you infer about P prime? Like how do you know what is P prime? And so there's obviously an equation for figuring this out, but I was getting very confused, and the reason is because this is a typo. So now let's go find what I'm talking about. Like let's actually talk about this. So we're going to go to courses, Rush Cryptography Engineering. We're going to go to week 2 session notes, and I'm going to scroll down, and I'm going to see. Okay, so what information, if any, can you infer about the plaintext P corresponding to C prime? And we know this is actually supposed to say P prime, and we made a mistake. So let's just, hit the edit button, right? Cool. You're making changes to a project you don't have write access to. Submitting a change will write to a new branch in my fork. So remember, I said I have my own fork, uncloak C. So you can send a pull request. So actually, I'm going to do something. I'm going to duplicate this page real quick so we can actually show my little repo, uncloak C. So let's go to my repositories, but same difference. Let's go down to uncloak C, and my repo is probably not synced. So there you go. I'm 5 commits behind Thor main. So because my repository is not in sync with the main website right now, the last thing that I have here is like 5 days ago. I'm actually going to sync my fork first, and just make it so that whatever I was doing. Usually, okay, I'm not sure if this is even the correct thing to do. So don't even listen to me, but usually sometimes I'll just use my fork as a way to just completely experiment, and a lot of times I'll just delete all my changes by syncing to the main fork, because if I do a good change that I actually think is useful, it'll get merged to the main branch anyways, and so my random experimentation usually isn't really, in my opinion, I don't need to save it. I just kind of wipe away those changes and wipe away those branches. But anyways, I'm going to update the branch so it's like fetching and merging, and there you go. Now we're up to date. So now that we're up to date, I should be able to come back here, scroll down, and I should be able to go to here, and I should be able to just see how this one says like C prime. I should be able to just be like, boop, P prime. And then I should just be able to be like, whoa, I updated this, changed P to, P prime, so that the question, makes sense. Okay. So I am, can't spell well, but, Grammarly helps as well. So if you're going to be contributing and you want to make sure your PRs look good. And I don't necessarily like changing the title because I feel like if it's on my own repo, I'll do crazy messed up titles to make sure I know what's going on. But because this is like a public repo, I'd rather just be very clear with everyone what happened. So like, session 2 notes got updated, that's good. I don't want to change that. And then if someone wants to see my random, like the way I do it, then they can read the actual like comments. So there you go. So yeah, this is not going to change. I don't have to worry about my randomness ever affecting the way it looks. So this is unverified. I can discuss and review with others, blah, blah, blah. But no, I'm just going to create a pull request. And the pull request is going to have the exact same information I had. So this tick at the bottom, obviously, I like keeping it ticked up. So maintainers of the repository, so in this case Thor, who's maintaining the Uncloak website, but eventually, let's say this was a DAO or a group of people or an organization or a company. The idea is that you're kind of doing what you can to contribute, and then if someone thinks that actually, this is what happened, so you're changing it from P to P prime. You're saying that you're changing it so that the question makes sense. If they say, actually, I actually think we need to add more information to this repo because actually that's a good idea, but maybe we want to add some extra information like, hey, you can find more information about why this question wouldn't have made sense here at this link, and sorry for making the mistake. as an example. But either way, allowing edits make sure that other people that are maintaining the repo can kind of edit it, and in my opinion, higher chance of the repo getting merged and accepted. The PR getting merged or accepted, because obviously instead of like having to resubmit a new PR, if you want to change something, they can just edit it themselves. But yeah, let's create the pull request. Boom! Didn't code anything, and yet I was able to hopefully fix this wonderful thingamabob. And so it'll have this weird like little patch thing, because it's like I went and like created my little patch of like a fix, and I'm going to merge that patch and all that cool stuff. I'm not very good with GitHub, but I'm learning, and I try and but there you go. I contributed technically three times, and they were all just fixes with the homework. But this is a wonderful way where anyone could have seen that and been like I said, we have a very active Discord. Don't switch, please. And you can go to the Uncloak Discord, and we can see all these study groups. We have the American study group, the European study group. These are like the study groups that are just starting based on time zones. We also have these themed study group, I guess. People just kind of deciding they want to group together. So there's a bunch of these. Polkadot cryptography study group. They chose a Pepe. So not all of these are very active. The Rust LeetCode one actually is relatively active so far, which is pretty cool. But most of the activity, in my opinion, is actually a lot of it in the forum, where people are kind of just being like, oh, key size versus block size, and like talking about mappings, and just like it's really cool seeing people just sharing their solutions in Discord. So if I'm like sharing anyone and putting them on blast, that's whatever. But this is cool being part of Discord. People are just sharing math solutions and talking about week one homework. And again, there's 115 messages in Find a Study Group. So there's study groups all over the place. My study group, currently is in just right here. So we have like people, discussing and sharing solutions. Like I don't want to share any like private things from anyone, but this is our study group. We have 10 members, so it is like technically full, if you want to call it that. But yeah, the Discord, in my opinion, pretty darn cool. But anyone who's kind of going through these questions is then able to be like, oh shoot, question 3 for chapter 2 doesn't make much sense. In the text, that oh shoot, it actually says P prime, and anybody can come along, go to the Uncloak GitHub channel, page. Again, I came from here. I went to courses. I saw the session 2 homework. So again. Maybe for course 1 solutions, I'm like, the answer here talking about birthday attacks, right? So consider a symmetric key crypto system in which cryptographic keys are randomly selected from a set of all n-bit strings. Approximately what should n be in order to provide 128 bits of security against birthday attack? So, you need to have n be 256, so that because you expect the collision in 100, you expect the collision in n 2 to the 128 steps, I guess. So actually, why does this look like this? I think on the site it looks fine. Let's double check, because maybe I could make another pull request if this doesn't look fine. Oh yeah, so it looks fine here. So it's just it looks like this. But let's say I wanted to add more information, because for example, in the Discord, there's actually a lot of people asking questions about birthday math. Had some a question was asked, and there was some good discussion about it, and some math even shared today, right? Someone tried, to share some math, and there's like a text edit bot. So it's pretty cool, what's able to be happening in Discord. But maybe we wanted to add some clarity to the website. And so anyone could actually come by, go to Course 1 Solutions, go down to question 7. Where are we? Question 7. And you could add whatever you want here. You could say, I think that we need to add more info here, right? and then you could just say, propose changes. I'm not going to do that because that sounds like a terrible idea. And if you don't want to do that, you just hit cancel and go, not be saved, please don't save that, yeah. And it'll just come back here. You can just go back to reading it. And you haven't done anything wrong, don't worry. So you can just, and obviously, if you propose a change that isn't supposed to be added, it won't get merged because someone's there to actually check it. So to me, that's anxiety reducing. I like that. Also, if you allow the maintainers to edit your pull request, then even if you write things in not the clearest way or the most efficient way, or you're maybe a little bit wrong, but you're mostly right, that's all right because maintainers, hopefully I will eventually be a maintainer, but working my way there. But the maintainers of the website can still kind of edit your content and kind of hopefully pay attribution to the editor. And I think part of the goals of Uncloak is figuring out how we do that efficiently on this site. But hopefully this was a relatively clear, and so you can see technically this has 2 contributors. I technically contributed. I committed in the past week, and obviously Thor committed in the past day. Working on it. But yeah, so that is kind of, again, compare and pull request. Isn't it already? Oh wait, do I have the ability to pull the what? Sorry, I'm trying to check now whether I have the ability to merge that PR that I just submitted. Pull requests. This one. No, I can't merge it. I can close it. So if you do feel like you don't like your pull request, you can definitely close your pull request. You can also leave a comment. You can say, hey, can you please merge this faster? Or hey, I want to add this to this. Or hey, I'm not sure if this is correct. People can discuss back and forth. You can see what the commits are, and you can kind of discuss a bit more. Oops, that's not what I meant to do. Just open it. Yeah. So you can see, what was actually changed. You can see which files, so if multiple files are changed, you can go through that as well. So yeah, I mean, again, there's nothing in the conversation because it's a relatively simple commit. There's a kind of some information there. And then obviously if Thor was like, what the heck are you doing? Thor can obviously respond with whatever there as well. And I guess I can edit it. Oh, yeah, edit the title. Nah. So if you want to edit the title, I usually don't ever edit the title unless I made a mistake. But yeah, that's all for this video. I'm about to actually stream right away again. I'm going to go through adding rewards to the December Marmajae ST Near farm on Ref Finance. So I'm gonna hop off. This has been going on for 32 minutes. Yeah, that's long enough. I think anyone who's watched this should hopefully understand how to contribute to Uncloak, or why they might want to contribute to Uncloak if they care about cryptography or cryptography engineering, or they join the study group, or they see any mistakes on the site, or if they want to write an article. You can all of this stuff is written by people who contributed, and anyone can go to any part of this site and just start writing about hardware and cryptography. So there's a topic right here, and you can kind of see what the topic is, and applications, recommended paths, and Allison, and you can start filling out this information just by coming here and hitting edit and just starting to write. And you can just start writing. And even if you don't exactly know what should go there, and you don't exactly have it perfect, you can just say, hey, I don't have this perfect, but I am trying my best, and I can't type. But there you go. And then you can allow the maintainers to edit your pull request, and then the maintainers can maybe add the context that's missing from your contribution. So don't worry about any of that stuff. I always feel a bit self-conscious when I'm, contributing to a public repository of information. But I think that's what makes this powerful, is that eventually we're having a knowledge graph that anyone can contribute to, and that many people do contribute to. So yeah, that's all for this video.